back, mathematicians. This lesson is going to be on random samples. So there is a lot of vocabulary in this one. So while it might be relatively short because I've already written out all of the vocabulary, um, these words and their definitions, the concept can be kind of difficult to grasp and understand because it's very subjective towards the problems you're looking at. And we'll get into that when we see some example problems. Um, but basically, for the beginning of the unit, we've been talking about statistics and we've been talking about data. And we've been giving data and putting it into a stem and leaf plot, a box plot, trying to find the quartiles, saying what that data represents. But this section, this lesson, is about how they collect that data. Um, and, uh, and and let's just dive in right to the definition. So we talk about data. Usually we get data to represent a population. So a population, let's zoom in here. A population is the number of people in the entire group. So if I want to take like the population of the United States, I would say that that's my population is just the amount of people that are there. Population of the world, I would count the number of people in the world. Um, Population of the school, I'd count the amount of people at the school. So those are all examples of the number for the population and then what it represents. Sample size. So sample size is what we use as a group. Okay, we use a sample to represent the population. And sample size is the number of people that are in that group. So, for example, um, if you're trying to find the, let's say, the average weight of a newborn baby, um, there are a lot of babies born, right? I don't know uh, what the exact data is. I think in the world it's about 250 babies are born per minute. So, if you wanted to find like the population of that, you would have to count up all of the babies that are born, right? And then find all of their weight and then take the average weight. So that is unlikely for someone to do, right? Probably impossible, the way I see it. But what we could do is take a sample size. Okay, so a sample size could be um, a representative of the population, right? So we could take, some people from the United States, some people from Canada, some people from India, right? A bunch of these different nations, and then we weigh those babies and we find their weight, and then we take the average and we say, well, the average weight of a newborn baby is about 7.5 pounds. Okay, so we're not getting that information by taking the weight of every single child that's born. We're only taking the weight of a certain amount of children that are born. And that's how we know, whether your newborn baby comes out and it has a healthy weight. Okay, so that's just one example of, how to take a sample and why samples are important to represent the population. So there are different ways to take a sample. Um, there's random sampling, which is also called unbiased sampling. That's a method of choosing the group that represents the population with certain characteristics. So those characteristics are every member of the population has an equal chance of being selected, and that selection of members is independent of each other. So it's like just because I chose Bob, then I have to choose Sue, right? That would be if it was dependent. So independent of each other means that just because I select Bob has no bearing on whether or not I select someone else. So those are random samples, and then we're going to get into particular types of random sampling. But let's first talk about bias samples. So bias sampling is a method of choosing a group to represent the population that is not random. And in this case, it would not be a good um, representation of the population. So, some examples of a biased sampling. Let's say that I want to see on average how many times or how many minutes per day you play video games. And my population is going to be everybody in the district and their families. And then I decide as my sample, I'm going to sample all of the adults. Okay. So not only is that not random, okay, I could say maybe I'm going to sample every other adult or every 12th adult. That would be kind of random, but it's still biased because the way I've separated those groups, um, adults probably aren't going to play video games as often as kids. So that average doesn't really have an accurate representation of the population. So that would be considered a biased sample. Another example of what might be biased is let's say that in the district you wanted to hold a survey about whether or not students like to come to school or even what their favorite subject is. And you're going to sample middle school students, right? But you're only going to do it from one school. So in that case, if there were 3 middle schools in the district, but you're only taking samples from one school, well, that school could have a significantly different opinion than the other ones. So that in that case, that would also be biased because you're not taking into account what the other schools might have to say. And there are ways to separate things into schools and still have it be random and unbiased. And that's what we're going to look towards next. It is some random sampling and then particular types of random sampling. The first type of random sampling is just called simple random sampling. It's called simple because it's pretty easy. You're just choosing members to represent the population without any pre-planned order. Um, so, for example, um, you could use like a frame. So let's say that you have a phone directory as your frame, okay? And then you just flip to a random page and then you randomly select a number and then you survey that person on whatever questions you're surveying about. Okay, that is just a random sampling. Okay, so like flipping a page in a book. Um, Another example of simple random sampling is a lottery method. So you give everybody in the population a number, and then you randomly select a number. And there are different ways to select a number. You could computer generate a number, like using an Excel spreadsheet. There are things called random number tables that you could do. So there are different types of ways to choose a number at random. That would be unbiased. The next type of random sampling is called stratified random sampling. In this case, you do have a pre-planned notion of how you're going to take a sample. Um, in stratified random sampling, you divide the population into groups, and these groups can't overlap. Otherwise, the chances of being selected are not equal and thus not random or equally random. So when you divide the population into groups, then you randomly select members from each group. So this would be like in stratified, you're separating them into 2 groups or 3 groups, and then in each group you're doing a simple random sampling. Um, so for things you want to consider for stratified random sampling is what will you use to create the groups? So what makes sense depending on how you're surveying the people, how you're collecting data. Um, does the population naturally fit into groups? Um, how many groups will there be? So do you need a lot of different groups? Um, you know, for just like a really basic example, if you're surveying and your population is 30 and the sample size you want is, 10, are you going to need to separate those into 5 different groups of 2? Probably not, right? So it depends on your numbers about how many groups you want there to be, and then how much data to select for each group. So you're going to pick 4 people, you're going to pick 5 people from each group. Okay, those are all things that you want to consider. Um, in this case, in stratified random sampling, the numbers in each group don't have to be equal. So, for example, if you were to survey high school students and you wanted to, just because it was easier, maybe to take the survey, you wanted to break them down into subjects. And so you did people that were in math, and people that were in science, and people that were in ELA. Well, the number of people that are taking those classes probably aren't going to be equal in the school. There might be more people taking math than there are ELA, and that's fine. So in stratified random sampling, it's okay for those groups to have different numbers of population as long as you're still randomly selecting within the group. Some examples for stratified random sampling. So let's say that you have 3 middle schools in the district and you wanted to find the average height of the middle school students. You can separate them into schools first, okay? And then you could send like one surveyor to one school, the other to another school, so on and so forth. And then that surveyor can then pick a random sample from each school. So that's one way to separate it, and those kind of separate naturally. Another way to separate into groups could be by gender. So you could separate a population by gender. Um, that kind of flows naturally depending on what your population is. So, those are just 2 examples of separating things into groups. So sometimes it makes sense to do groups, other times it doesn't. So there's going to be so many different scenarios of taking random samples, and it's all really subjective. There's not always one correct answer. Um, you could justify a lot of different types of random sampling for different situations. So it's one of those um, that you can pick like one answer, and as long as you can justify your answer, that can be correct. Let me just zoom in a little bit so you can take down these notes a little bit better before we move on to the next page. The final type of random sampling is called systematic random sampling. And this is when you select the first member randomly, and then you select the other members in equal intervals. So, for example, um, let's say that you are doing a walking survey, and one way to do it randomly is you just pick a random house, and then as you walk down the street, the house you survey is every 12th house that you see, right? So you have a plan, right? So it's just a systematic plan of every 12th house, but it's still random because you started out random. Another one could be every 8 minutes. So let's say that you're just standing around at the mall, and then um, you want to take surveys, but you don't want it to just be like, because you're standing at one place, everyone you're surveying is going to be from this one place. Let's say that you move around, okay, and then maybe every 8 minutes you pick a person and you take a survey from that person. And then you walk some more, and then 8 minutes go by and you pick another random person, right, and you survey that person. So that could be like every 8 minutes. Um, every 200th item. So this one is popular for factories that test defects in their items. So especially like phone manufacturers, they're going to randomly select a tray of phones and check and see if there are defaults. They might select every 200th tray of phones and sample those and see if there are any defects. If they find a defect, then probably that round of making those phones, they're going to take those off and then make sure that that round or even that day that they checked, all of those phones are working. Okay, so that's a systematic way of checking for defects. And sometimes, even if you have a systematic way, there can still be defects. So we see that in, especially in phones. Nowadays, we had the Galaxy Note um, that that started catching fire. Right? They had a systematic way of sampling and testing these phones. They didn't test every single phone, right? They didn't sample and check every single phone, but somehow that defect wasn't detected in the random sampling. So when it went out and it was mass produced, that's what happened. They ended up catching fire. Another one could be the Galaxy Fold, right? They said that they tested that folding technique so many times, and it worked out great. But maybe it only worked out for those every 1,000th phone that they tested, because when it came out, these phones started bending the wrong way or the mechanism broke. So sometimes there are problems with the way you sample, and there are defects that kind of go away, but you can still have a systematic approach to them. And just so you can see the notes better, let me kind of zoom in here. You can pause there to take those notes down if you need to before we move on to the next page. For this last page, we're going to get into some situations, and we're going to see which method of random sampling we would choose, and how we would do that, and why we chose that method. So the first one, so the scenario is a journalist would like to find out what attendees think of the larger computer fair, or of the large computer fair they're attending. He decides to interview 50 people. So should he do a simple random sample, which is just selecting people at random with no preparedness? Should they do a stratified random sample, and with these 50 people, separate them into groups, or separate the computer fair people that are attending into different groups? Or should he do a systematic random sampling, and say every 12th person he's going to sample? So which one would be easiest? And you can justify a lot of these ones. Um, for example, so the one that I choose here and the one that I justify might not be the one that you choose, but as long as you can justify your answer, we both can be correct. In this case, I think that just a simple random sample would work, because they're not really doing an in-depth survey. They're just doing kind of a quick one about how they feel about the large computer fair. So it seems that it's going to be like a quick kind of general sense of what the person is feeling. So probably a simple random sample would be fast. So it would be faster. Okay. And then how they could do it is they could just walk around and randomly pick 50 people. Now, I could probably justify a systematic approach as well, is let's say you just stand by the door, and every 5 people that walk through the door, you survey them. So that would be a systematic approach that you could also justify. The thing about that is, what if you're standing by a particular door that creates a bias? So those are all things that you have to be careful of and what you have to think about when you're sampling. Scenario two, um, a poultry farm keeps 3,000 birds. An agricultural safety and health officer needs to check whether any of the birds might be infected with a virus and would like to take a random sample of 20 birds for inspection. So, which of the three um, random samples makes sense? For me, when I see that there's such a large population, so you have 3,000 birds, and you're trying to do this as fast as possible, I'm thinking a systematic approach would make sense. And then how could we do that? Well, let's think. We need to um, have 20 birds inspected out of the 3,000. So that's 3,000. And we divide that by the 20 that we need, right? So that means that you check every 150 birds. Okay, so that's usually how you choose a systematic approach is you find your population and then you divide by the number of people that you want to select. And that way you know how many to count off by. And let's take a look at our last scenario, which is scenario three. So a local authority plans to conduct an opinion poll of people in McCree County as to whether they are in favor of putting more restaurants in the historical landmark site. The county consists of 6 districts. The authority intends to generate a random sample of 300 to 400 people. So when I see this right away, it says that the county consists of 6 districts. So right away, I'm thinking stratified. Random sampling. And remember that stratified is when you have groups. Okay, so you break it down into, in this case, 6 groups because there are 6 districts. So I chose stratified random sample because they are already separated into groups. Okay, and let's see, how would you do that? Well, you have 6 districts, right? So let's make a table. So there's District 1, 2, 3, 4, 5, 6. And then how many people should you survey in each group? Well, you want 300 to 400. So somewhere in between that, let's say you could do 50 from each group. If you did 50, well, 50 times 6, that would give you 300, right? So 300 people. And we're trying to figure out how many people to survey. But we really don't want to, if it says 300 to 400, we want to be somewhere in the middle. So maybe instead of choosing 50 from each group, we choose 60 from each group. And we do 60 times 6, and that's 360. So that's between 300 and 400. So we can say 60. Okay, so randomly select So you would randomly select 60 people from each group or from each district. Okay. No practice problems for this one because they're so subjective. Um, what you're going to do is you're going to move on to the practice from the textbook. And again, there's going to be multiple answers as long as you can justify why you chose that random sampling method, or you can justify a reason why a certain method of sampling could have bias, then you can justify it as being correct. So I know that there was a lot of vocabulary in this one and a lot to take in. So take your time with the problems. Don't get frustrated. And I would definitely have the definitions with you as you start doing these problems.